So let's try one more example here. We have to prove a trigonometric identity involving some half-angle formulas. Tangent x times tangent of 1/2 x is equal to secant x minus 1. So this one's a little tricky, but it's going to be a lot easier if you remember an example we did in the earlier part of the lecture where we figured out a trigonometric identity for tangent of 1/2 x. We figured out a half-angle formula from the earlier example. We proved that tangent of 1/2 x is equal to 1 minus cosine x over sine x. And that was a little bit of work to prove. Actually, that involved removing some plus or minuses and some square roots. That was actually kind of tricky. But having done that work, it will be pretty easy to prove this trigonometric identity. So let me start with the left-hand side because that one looks a little more complicated. And I'll try to manipulate it into the right-hand side. So the left-hand side is tangent x times tangent of 1/2 x. Now this tangent x, I'm not sure exactly what to do with that, so for lack of a better option, I'll convert that into sine x over cosine x. That's the definition of tangent, so you can always convert tangent into sine over cosine. Tangent 1/2 x, that's not so obvious, but I remember this previous example where we derived this identity, 1 minus cosine x over sine x. So I'm going to convert that into 1 minus cosine x over sine x. Now, the sine x's cancel, and so we're left with 1 minus cosine x over cosine x. And if I split that up into 1 over cosine x minus cosine x over cosine x, then 1 over cosine, by definition, is secant x. And cosine over cosine is, of course, 1. And look, we've transformed it into the right-hand side. So again, as with most trigonometric identities, it's not always obvious how to proceed with them. But a general rule of thumb is try to attack the more complicated looking side first. In this case, that was the left-hand side. Tangent of 1/2 x, I remember my half-angle identity for tangent of 1/2 x that we proved earlier on in the earlier part of the lecture. I expand that out. I don't know what to do with the tangent, so I just convert it into sine and cosine. That's kind of something you do if you can't think of anything else to do. Convert everything into sines and cosines. And then it starts to cancel nicely, separates out, and it suddenly converts into the right-hand side once I remember the definition of secant x. So the general rule is there, go for the more complicated side, convert into sines and cosines, and invoke any half-angle, double-angle, or other trigonometric identities that you already know. So that's the end of the half-angle formulas as part of the trigonometry lectures on educator.com. Thanks for watching.